Hi class, in lesson 8.5 we will be combining like terms. Learning targets for lesson 8.5, we will be developing models for algebraic terms, using models to combine like terms in algebraic expressions, and combining like terms in algebraic expressions. Let's take a look at problem number 1 on page 576. We are going to be using algebra tiles in order to model algebraic expressions. We can also just use colored pencils in order to help us differentiate between the tiles. So I want you to use yellow to represent x, orange to represent y, green to represent 1, red to represent x squared, and blue to represent y squared. If we take a look at number 1, the dimensions of each of the tiles for letter A, this tile is going to be 1 unit by x units. Again, that's going to be represented by yellow. Letter B, this tile is 1 unit by y units. This is going to be represented by orange. For letter C, this tile is 1 unit by 1 unit. That's represented by green. For letter D, this tile is y units by y units. That's going to be y squared, represented by blue. And for letter E, this tile is x units by x units, x squared, which is going to be represented by red. Let's take a look at number 2 on page 577. It asks us to represent each algebraic expression using the algebra tiles and their operation symbols, and then to sketch our model. And like I said, we're just going to use colored pencils so we can tell the difference between each of the tiles. So the algebraic expression for letter A is 3x squared plus x plus 2. So you can see that I have the x squared models, the tiles represented by the blue models, plus the x, which is represented with yellow, plus 2, which is represented by the green squares. So go ahead and do the same thing for the rest of number 2. I want you to answer letter B through letter E onto the top of the next page. Here is what your sketch should look like for letter B. I would have 2 greens representing 2 plus x squared. I would have 1 red plus y squared. I would have 1 blue plus another green for adding 1. For letter C's expression, 3x plus x plus 2y, I would have 3 yellows plus another yellow plus 2 oranges. For letter D's expression, 5x plus 1 plus y squared plus 3, I would have 5 yellows plus 1 green plus 1 blue plus 3 greens. And finally, for letter E, 2x plus 3 plus 3x plus x squared, I would have 2 yellows plus 3 greens plus 3 more yellows plus 1 red. Let's take a look at number 4 at the top of page 579. It says to rearrange the tiles in question 2, part C, so that there are only 2 terms. Letter A says to sketch your new model, include the operation symbol. Letter B says to write the algebraic expression that is represented. And then letter C says, could you rearrange the tiles so there was only 1 term? Make sure that you explain your reasoning. And what are the terms that can be combined called? So go ahead and do number 4, letters A through D. If we take a look at letter A, this is what your new sketch should look like, and you can see that we combined the x's in order to have 4 of them together instead of 3 plus 1 for the x's that are represented in that algebraic expression. So then the new algebraic expression that would be represented would be 4x plus 2y. For letter C, you cannot combine all the tiles using only 1 term, because the tiles for the x and the y are different. And when we combine terms like this, we call them like terms for letter D. Let's take a look at number 5, same question. We want to rearrange the tiles in question 2 now for part B to reduce the number of terms to the fewest possible. Again, for letter A, sketch your new model, include the operation symbol, and for letter B, write the algebraic expression represented, and finally for C, could you rearrange the tiles so there was only one term? Explain your reasoning. In this particular example, we combined the green tiles that you sketched back in question 2 for part B. So our new algebraic expression should be x squared plus y squared plus 3. We have 3 green tiles now that we can combine. And again, you cannot combine all the tiles using only one term because the tiles are different. You have them down to the fewest number possible for letter C. Let's take a look at number 6. Again, rearrange the tiles in question 2 for part D to reduce the number of terms to the fewest possible. Do letters A, B, and C for number 6. Here is what your new sketch should look like for number 6. Your algebraic expression would now be 5x plus y squared plus 4. Again, you cannot rearrange the tiles so that there are fewer terms because the tiles are indeed different. And let's finish up doing the same thing for number 7 for question 2, part E, to reduce the number of terms to the fewest terms possible, letter A, B, and C for number 7. Here is what your new sketch should look like for number 7. Your new algebraic expression should then be 5x plus x squared plus 3. And again, you cannot rearrange the tiles so that there are fewer terms because the tiles are all different. Let's move over to problem 2, but we are going to start on page 584 with number 2. We want to represent 2x plus 5 plus 3x, again using our colored pencils for our algebra tiles along with the operation symbols. I'd like you to do letter A, sketch the model of the expression, and letter B, write an equivalent algebraic expression by combining like terms. Here's what your sketch should look like for letter A. You should have 2 yellows plus 5 greens plus 3 more yellows, and when you combine the like terms for letter B, your algebraic expression should be 5x plus 5. Let's look at number 3 at the top of page 585. Represent 7x plus 2x squared minus 3x minus x squared, again using our colored pencils for our algebra tiles, and make sure that we include our operation symbols. Letter A, sketch the model again, and letter B, write the equivalent algebraic expression by combining the like terms. Here is what your sketch should look like for number 3. We are going to have 7 yellows plus 2 reds minus 3 yellows, and then we are also going to subtract 1 red. For letter B then, your equivalent algebraic expression, when you combine the like terms, you're going to have 4x plus x squared. Problem 3 for lesson 8.5 is going to be homework for tonight. I would like you to do numbers 1 through 6. You are going to simplify each algebraic expression by combining like terms. If you're comfortable using your colored pencils, go ahead and do that. As far as modeling your sketches like you did throughout the lesson, I want you to take a look at the word bubble here. Make sure that you're looking for the same variable when you're combining like terms, the same exponent when you're combining the like terms, and make sure that you pay close attention to the operation symbols so that you are simplifying those expressions when you combine those like terms correctly. That's it for lesson 8.5 on combining like terms. Please let me know if you have any questions.